Hello friends, welcome to Learners Forum. So the next topic is about voltage division rule and current division rule. So these rules are very important to solve any problem. So to know the voltage division rule, let us consider a circuit where we have a voltage source and two resistors R1 and R2 are connected in series in this way, and the current flowing through is I. So since the resistors R1 and R2 are connected in series, as we have seen in the series connection characteristics, the current value remains the same. That is, across R1 we have the same value of current, and again across R2 resistor we will have the same value of current. So to calculate the voltage across each resistances, that is VR1 and VR2, let us take the Ohm's law, which is in general given by V is equal to IR. So since it is taken across the resistor R1, let us take it as VR1, which is equal to I into the corresponding resistor R1. Now we can replace the value of I in this equation as, so the current flowing through is I. So from this equation we can write I value as V by R. So V divided by, since we have two resistors in series, the total resistance value will be equivalent to R1 plus R2. So that is written over here instead of I, and the remaining R1 is written here. So we can rewrite this equation as R1 divided by R1 plus R2 into the remaining value V. Similarly, we can find the voltage across the resistance R2 as VR2, which is equal to I into the respective resistor, so R2. Again, we can take the value of I as V divided by the total resistor. So whenever the resistance are connected in series, the equivalent resistance will be the sum of resistances as we have seen before. So R1 plus R2 into the remaining value is R2. Again, we can rearrange this equation as R2 divided by R1 plus R2 into V. So, the voltage division rule is nothing but the ratio of resistance value to the total resistance. That is, this is the equation for VR2. So, it is equal to the ratio of resistance value to the total resistance value multiplied by the source voltage. So, since we have R2 here, the same resistance is considered for the numerator divided by the total resistance, which is R1 plus R2, multiplied by the source voltage, which is nothing but V. Similarly, the same thing for the first equation also. Here also, since it is for VR1, whatever resistance we are considering it over here, that is to be taken in the numerator divided by the total resistance, which is R1 plus R2 into the source voltage. The source voltage in the circuit is V, so that is taken over here. So this is the voltage division rule. So for any circuit, the voltage division rule is nothing but the ratio of the resistance value divided by total resistance multiplied by the source voltage. So this is the voltage division rule. Similarly, we will see it for the current division rule now. Now let us consider this circuit where the voltage is connected with two resistors which are connected in parallel in this way, R1 and R2. Here this resistance R1 and R2 are in parallel connection, which means the current flowing across these resistors will be divided. That is, if we take this as the total current IT, this will be getting divided in this branch as I1, and across this branch we will have a current of I2, which means there are different currents flowing across these resistances, whereas we will have the same value of voltage, which is nothing but V. So the total current value will be equivalent to I1 plus I2. Now we will calculate the value of I1 and I2 separately, which is V by R1 from the V is equal to IR equation. Similarly, I2 is equal to V divided by the corresponding resistance. So it is R2. That is I2 in the sense the voltage is same, so we will have the same voltage. The resistance value for this particular branch will be R2. So here it is taken as R2. So from this equation we can write it as V is equal to, just by multiplying I1 into R1. Similarly, V is equal to I2 into R2, which means both are equal to voltage. So we can just equate this. So from this equation, let us consider the value of I1 alone, which is equal to I2 into R2 divided by R1. So this will be the value of the current I1. Now we need to find the value of the total current. So total current value is IT, which is equal to I1 plus I2. We will substitute this particular equation of I1 in this equation of IT. So I2 into R2 by R1 plus the remaining value of I2. Now let us rearrange it together to get a standard form, which is I2. We can take it in common, and after taking LCM we will get R1 plus R2 divided by R1. So the value of I2 will be, we have calculated the value for IT, from which we can calculate the value of I2, which is equal to R1 divided by R1 plus R2 into IT. Similarly, if we calculate the value of current I1, this will be equal to R2 divided by R1 plus R2 into the total current I2. So we can define this current division rule as ratio of opposite branch R. That is, we have seen it for I1, but the opposite branch current will be R2. We have seen the resistor connection, which is connected in this way, R1, R2, and we have the current flowing IT, here I1, here I2. So the current flowing across I1 will be equivalent to ratio of the opposite branch. So the opposite branch is nothing but R2. So R2 divided by the total resistance. So here we have the total resistance as R1 plus R2 into the value of total current, which is nothing but IT. So this is the current division rule. Similarly, we can see that in case of I2, we have the opposite resistance as R1 divided by the total resistances, that is R1 plus R2 into the total current, which is IT. So this is the equation for current division rule. We have to make sure that we remember this voltage division rule and current division rule, because to solve any problem, the basic thing will be this voltage division rule and current division rule.